one or two of your problems reminded me that maybe it's a good idea to look at this and explain some of the basics of this thing. So congruence means equal, okay? Triangle congruency means that two triangles are congruent if those triangles have the same length, sides, and the same size angles. They are exactly a copy of the triangle. And you could look at, for example, oops, no, I don't want that. They moved it around on me, Pete. There we go. You can look at separate triangles like I did here, and it'll give you the idea, but oftentimes they kind of push the triangles next to each other so that you'll see in a few minutes. But see these triangles, if we put like a 1, 1, 2, 2, 3, 3, it means that if this side is length 5 centimeters, so is this one. These are the congruent sides. And we often have like letters at each vertex so that we can say things like, A, B, C, D, E, F. And you can say, side DE is the same as or congruent to side in the other triangle AB. And you got to try to line the letters up. A BA would be the same thing as AB, right? AB, BA. It just means the distance from A to B or the distance from D to E, okay? And they sometimes put a line over the top. So there are, obviously, if you measured all the sides of both triangles and all the angles of both triangles and it was all the same, you would be like, oh yeah, they're the same. But we have shortcuts. We don't have to measure everything to really tell if both triangles are congruent. We can just measure certain things, and that's what this is over here, okay? So there's AAS, SSS, whoops, let's undo that, okay? And ASA, angle, angle, side, 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 and angle, side, angle. There is no ASS, that's ass, but these are the three that if we find out these three pieces of information that the angles of one particular angle of each of the two triangles is the same, another angle we can measure, and then one of the sides of each triangle, then we don't have to measure the other angles and the other sides. We know just based on this little bit of information that the triangles are going to be the same size. So we kind of write it like this, side, 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 and these are usually like given as answers or reasons why the triangles are congruent. Those two triangles are congruent because side, side, side. So, yeah. So let's have a look at it. The first one shows you that side FG is the same as side GH, right? And so you can say that you have that piece of information. This side and this side, and you can see the angle here. And since this side here is common to both triangles, obviously the GI in this triangle is the same as the GI in this triangle. So you could actually say GI, like I did right here. You could say GI congruent to GI, right? Because it's a common side, right? So, and that would be the good one to know in this case if you wanted... whoops, I forgot side, angle, side, didn't I? Side, let's do this, side, angle, side. Sorry about that. So that means that since this side is congruent to this side, and this angle is congruent to this angle, and this side is congruent to itself, this is called side, angle in the middle, side, angle in the middle, side, angle, side, angle, side. So the order kind of matters here a little bit, right? So these two triangles are congruent because of side, angle, side. You could actually use that. These two triangles, triangle F, you would even see it written this way, like, let's see, triangle F, G, I is congruent to triangle, and FGI, I'll try to keep it the same, HGI. right? And the reason is, and that's probably what they actually wanted me to put in the number one, the reason those two triangles are congruent is side, angle, side. I'm actually not even sure right now if that's one of them, the side, side, side. I might have given you some bullshit, right? But let's see. Maybe it is. Yeah, I think it is. Okay, so been a while, 10 years. I'm like, oh, did I remember this? This one has side, congruent to that side. Yeah, this is my side, side, side. So I was right. Side, side, side. Whoops. That means that three different sides of one triangle are congruent to three different sides of another. Okay, OP is congruent to QP, NP is congruent to NP, NQ, and NO, right? This one is what we would need here for each pair of triangles. State the postulate theorem that can be used to conclude that the triangles are congruent. So this one here, now one thing you should know, and it kind of is intuitive, I think, is when you have two lines crisscrossing, this is going to be used a lot in these things. Two lines crisscrossing like that, these angles that they make are going to be the same angle. Okay, so you can actually write it in there. I would write it with two of them now. 1, 2, 1, 2, and that just tells you that angle BCA is the same as angle DCE, or something like that, okay? Or actually ECD, I should say. ECD, BCA. The two triangles are congruent because of, now this one is, I'll show you on the left-hand side here, angle, side angle, ASA. The reason that they're congruent is because of ASA. The reason the two triangles are the same. Because you have sort of the S is in the middle here, okay? And the A's are on the outside, right? So you can look at it like, well, the S is in the middle here, the side, and the angles are like on left and right. You know, the side is sort of in the middle, like here. Okay, so you could go on and on. This one here, obviously that side's congruent to itself. So this would be angle, side, angle, right? Angle, side, angle. This would be angle, angle, side. The side's not in the middle of those two angles, is it? Okay. Angle, angle, side. Stop this and see if you can get them. Side, angle, side. Angle, angle, side. So this kind of gives you an idea on